Okay, I know how to go and put a space probe around Beta Centauri and get back the data in 22 to 24 years. I invented a new type of rocket that'd make it possible. The trick would be to not decelerate at the halfway point in the journey, but to keep accelerating all the way there. It might even be possible to achieve the speed of 1/10 of the speed of light. The planet's been detected thanks to the Kepler Space Telescope in orbit around Beta Centauri, our nearest star, which is 4.2 light years distant. Closest star. It's an Earth-like planet, a little bit bigger than the Earth, in orbit around a red dwarf star, smaller than our sun, cooler, but the planet's closer in. It lies within the zone of temperature that'll support life as we know it. It's got an oxygen-argon atmosphere, breathable. It's got water and all 4 of the amino acids necessary for DNA. It's a planet that we could colonize. The secret lies in using an asteroid as the space probe. A nickel-iron asteroid. Has to be nickel-iron. And the fuel, the propellant, would be the asteroid itself. The nickel and the iron, using basically a rapidly boiling vat of molten nickel and iron, powered by maybe a 10 megawatt nuclear reactor, using a magnetic induction furnace rocket nozzle to melt the iron. Propellant. For every reaction is an equal and opposite reaction. And the oxygen, hydrogen rockets that we have, iron and nickel, are one hell of a lot heavier. It'll work as a rocket. You have to have some robots on there, maintenance robots, control robots to mine the nickel and iron and feed the rocket nozzles. It'd work. Once it gets out there, it finds one of the gas giant planets. It does an atmospheric braking maneuver around it, goes into orbit around that planet, sends back sensor data, which will take 4.2 light years to arrive. The trip should take 16 to 20 years, something like that. And the data will take 4.2 years to return to the Earth. Yes, I'm a rocket scientist. Interesting, isn't it?